Alan Forsberg here with a framing video on soil systems and climate change.
We overlook it. We walk all over it, trample it every day. Yet we need it, like the air we breathe. It's about time that we talk about soil. And certainly about time that we start protecting it. There can be no life without it. It feeds us, and we are responsible for it. Soil is formed from rocks that are decomposed slowly by the sun, the wind and the rain, by animals and plants. In this way, 10 centimeters of fertile soil are created in 2,000 long years. Only 10 centimeters in 2 millennia. Soil that we deplete in only a few years, gone forever.
So when we're looking at living aspects of the system, first thing that we should consider is that the Earth, the lithosphere, and the atmosphere, and the biosphere, and the hydrosphere, all of these things are coming together in the form of soil, in the form of dirt. The official IB definition of soil is a mixture of mineral particles and organic material that covers the land and in which terrestrial plants grow. So it's kind of specific, and it mentions both the organic and the inorganic, and it mentions the living and the non-living and where we're going to find it. So if we move into our definition of soil, what we see is that it's this interactive place, the place where everything is going to meet together, where we're going to have different kinds of interactions, where we're going to have precipitation, evapotranspiration, we're going to have different flows over the land, we're going to have infiltration. So a lot of things are happening. And it is this mixture of a lot of different things. Primarily, rock is going to be how we get our first part of it. Remember, if you go back to think about your lessons on weathering, back in probably 6th or 7th grade for most people, looking at the dead organic matter or the decaying organic matter, water, air, and once again, all of those living organisms that are located within it. Our planet is the only one that has a living, breathing skin, and a lot of time we don't consider dirt or soil to be alive, and we also have to consider the connotations that go along with saying something is dirt or dirty. We have this opinion that dirt belongs outside and it's not something that we're really connected with. But what we have to consider is that we depend on soil, we depend upon dirt, and dirt is alive because it has so many different things that are going on with this. So if you take a look at this fact, in a 1/4 teaspoon of fertile soil, these are all the different kinds of things that we have in there that we're not considering when we're doing things like paving over or not taking care of it. So when we look at soil, we have to remember that there are many biotic things that are going on inside of it, that it's not just minerals, that it's not just what we consider to be soil, that there is a lot of processes that are happening within it.
Carbon dioxide is one of the key gases responsible for causing climate change. But healthy soils can be a strategic ally in mitigating and adapting to climate change. This is because soils sequester and hold carbon dioxide, preventing it from escaping into our atmosphere. There is more organic carbon in our soil than there is in our ground vegetation and atmosphere combined. Worldwide, 1,417 petatons of carbon are stored in the first meter of the soil. 456 petatons of carbon are stored in the above-below ground vegetation and dead organic matter. Organic matter plays a critical role in sequestering carbon dioxide. The higher the organic content of the soil, the higher its sequestration potential. However, soil degradation through deforestation, loss of nutrients, compaction, erosion and waterlogging, and urbanization cause our soil to emit greenhouse gases that contribute to global warming and climate change. But if we protect our soils and manage them sustainably, we can combat climate change.
If you were asked to picture the world's largest treasure, you might imagine a large vault filled with chests of jewels and gold. But the world's largest and possibly most important treasure is buried right beneath our feet. Soil holds massive amounts of organic matter, which increases its ability to store and release the nutrients essential for plant growth. Soil organic matter also increases soil porosity, allowing it to store enough water and air for plant roots. This means soil organic matter forms the basis of soil health and fertility, and so food production. But it carries out another crucial function. It captures carbon from the atmosphere as soil organic carbon. Plants fix organic carbon in soils through debris, roots, and fluids. Soil fauna break down these residues into soil organic matter. Some of this organic matter remains as soil organic carbon. Some is naturally released into the atmosphere as carbon dioxide. It is when we lose soil organic matter through human activities that we face problems. The degradation of 1/3 of the world's soils has already released up to 100 gigatons of carbon. Yet an estimated 1,417 gigatons remain in the first meter of soil across the globe, almost double the carbon in our atmosphere, and dozens of times the levels of man-made emissions each year. It is clear that losing the soil carbon treasure would increase carbon emissions and accelerate climate change. But we can do something about it. Many physical and biochemical mechanisms protect soil organic matter from decomposition. Soil management practices influence these mechanisms and can bring carbon gains or losses. Since soil organic carbon is highly dynamic, we need to find innovative ways to sequester more carbon by adapting strategies to local conditions. We also need to monitor and report changes in soil organic carbon. And we need to maintain soil organic carbon stocks in vulnerable hotspots. Peatlands, permafrost soils, and black soils are particularly prone to carbon losses. Grasslands store more than double the amount of carbon in all other agricultural areas. Drylands are important because although they have low carbon content per square meter, they cover a large surface area. Scientists have already demonstrated the many sustainable soil management practices that can preserve and boost soil organic carbon. Governments now need to support land users to implement them. This is a huge task, but an even bigger opportunity. We can enhance resilience to extreme events. We can restore soil fertility to provide cleaner water and nutritious food, and preserve terrestrial biodiversity. And by rehabilitating the world's degraded soils, we can remove up to 51 gigatons of carbon from the atmosphere. There can be no doubt that joining forces to protect and increase the stocks in the soil organic carbon treasure represents a sound investment in fighting the most challenging environmental issue of our time, our changing climate. Soil organic carbon. Unlocking the potential of mitigating and adapting to a changing climate.